All right, so what we've been doing so far is executables, exe files, and things that are compiled down to assembly to a machine code for the processor directly. And now let's talk about .NET, which is really important. It's Microsoft's competitor with Java, and so .NET runtimes are not compiled down to machine code. They are compiled down to something called intermediate language, and then they run in a virtual machine called a .NET runtime, which is analogous to Java. Java compiles to an intermediate thing called bytecode, and it runs in a Java virtual machine. So, and it's very popular for the same reason Java is. In principle, it's cross-platform, which is why people love Java, and I don't really know why Windows developers love .NET, but they do. I've had students in my workshop say it's better for large projects to use .NET. Anyway, it's used a lot, and it's an important skill to understand how to reverse it, and it's much easier to reverse .NET files than Windows executables. So, the file we're using is this thing called PMA 132, which just contains some .NET stuff that I got from a Capture the Flag contest. So I've downloaded it here. I'm going to unzip it with right-click, extract all, extract. And in there's a folder. And in that folder, there are two files, challenge1 and pma132.exe. And they're both executables, but they're not normal Windows executables. They are .NET executables. So I'm going to close all these other windows, and we're going to run it in x64 debug. Now, I don't know why this is true, but for some reason, you can't run this directly in the Windows 10 environments I've got here. They must have the wrong version of .NET or something, but it runs in the debugger. So the 64-bit debugger I mentioned before, which is basically a modern upgrade from Ollie debug, will run this code. And I don't know why it won't run in the native operating system, and I wasn't really very interested because the only point of running it in this debugger is just to see what it does. So I do File Open, and I go into Downloads, PMA132, and I run challenge1. And there it is loaded, and there's the assembly code and such, and you run it here, and now it's going to tell me it needs .NET Framework, so just agree and download whatever it needs. It will download some .NET thing. Okay, and maybe it's not going to run on this machine. It's telling me some reason it can't run. Let's see if it's lying or what. Well, the fact that I can't run it is mildly annoying and indicates that there's some kind of problem with the .NET on this machine, but rather than debugging it, it'll probably work for you. When you run it, this is a picture of a dog, of Bob Ross painting a picture with a dog on it, and there's some scrambled junk up here. And when you click the decode button, the figure changes, but the text just changes to unreadable characters. So the point is, there's an encrypted message here, and there's some decoding code, but you can't see it in the GUI. So we're just going to reverse engineer this code, and the fact that I can't figure out how to run it doesn't really matter. We don't really need to run it. I may try just a little bit more. Let's try running it in the host system here. Terminate everything. And now if I run it directly here with right-click Open and run, I wonder if it's going to do that thing where it installs something from .NET. Here it is, saying it needs this feature. Download and install this feature. And now it's trying. Couldn't be installed. So I wonder, just a moment, let me see what Microsoft says about how to solve this problem. Check your internet connection, group policy. Yeah, okay. Anyway, we don't need it for this project. I'm just going to skip it. This, by the way, the same thing happens with Java all the time, too. You may have noticed, very hard to run Java. You often have the wrong Java installed. You can't find the right one. So .NET is similar. Anyway, we're going to examine this with CFF Explorer, a tool we've used before. And in here, the file type is portable executable 32.NET assembly. So it's 32-bit .NET assembly. That's all we need from this tool. That's how we'd find out it's running .NET. Now, we can examine it with ILSpy for intermediate language SPY. This is one of several .NET reversing tools.
Your page says 23 instead of 32.
Oh, thank you. Well, that's not right. Good. All right. Anyway, so let's, all right, now we're going to open it in the left pane. We load this program, which is going to be downloads, 132, challenge 1. Okay. It loads it. Now notice, and the same thing happens when you analyze Java, by the way. There's a bunch of extra things here, which are system fails. And by the way, I wonder if I can make the font bigger. Let me just check and see if that's easy. Display. Font. I thought it was easier. Let me just try a bigger number here. All right. It doesn't change the part that's too small. Anyway, here's the challenge 1. And so this is the part that matters, and you can expand it here and navigate through it. And so we want to expand resources, and then here's Rev Challenge. There's a thing called DAT Secret Encode. All right. And we want to find button decode, which is down here in the form. You expand this one and the form, and in here you find button decode. Click object. And here is the code. And notice .NET Intermediate Language is reversible into readable source code. This is C#. You can view it in various languages. Here's the raw intermediate language. This is what it does to compile it, which looks sort of like assembly code, but you can view it as C#, and with other tools you can view it as Visual Basic. So this is a thing people should understand about .NET code. You're distributing code that for all intents and purposes includes the source code, which is not true of programs compiled from languages like C. So this is the decrypting. It takes the secret data in DAT secret and it shifts it right forward, so it takes the left byte and shifts this left forward, so it takes the nibbles, the two 4-bit parts of the 8-bit, and exchanges them, and then it XORs it with this static value 29 in hexadecimal. So it's a pretty simple operation to decode things. So now we know the decoding, and we just need to get the secret data, and we saw that earlier. That was up here. DAT secret code was in the resources. There it is, DAT secret encode. And you can just save it from here. So I can save that in this folder. Now I have the data, and now I can just decode it with Python. And here's a Python script that will do it. I'm just going to go here. Now, these machines already have Python on them because it comes with Ollie Debug. So I can go to the folder where I am, which is downloads, and then PMA 132. Whoa. And then PMA 132, and make my window a little bigger. All right, now if I do a directory, there it is. And so I can make a file, notepad solve.py, and then I'd put that Python code here, and when you get it right, it'll just decrypt that file and you'll see the secret. So I'm not going to finish that one. I'll let you get it to get the flag. You'll see it has an email address looking thing at flareon.com, because this was part of the Flareon challenges, which comes from Mandiant, which wrote this analysis textbook and defined this whole field, really, of malware analysis and such. And then there's another file here with a similar thing to solve. And then there's MemeCat Battle Station, which is fun. Let me point out this one. This is another puzzle to solve with .NET. Let me go here to my page. If I can get this garbage off my screen. Okay. Everybody in tech always has to add new garbage that I don't want and put it in the way. All right, .NET. So let's download this thing. All right. And run MemeCat Battle Station. There, this one runs. Okay. So it's a game. There you are. And what you have to do is you have to put in an arming code. And if you don't know, if you put in the wrong arming code and fire, then you don't get to fire and you have to shoot in time. And so you just have to find these arming codes that are in the source of this object. So if you load it into ILSpy, you'll find information about these things. And by reading that code, you can figure out what the right arming code is and find the hidden flag. So that's the joy of .NET. I'll stop this one.